What brain regions cause motivation loss in schizophrenia? Imagine trying to get excited about something, but your brain just won't cooperate. That's what happens with motivation loss in schizophrenia. It's a part of the negative symptoms that make everyday tasks feel overwhelming or pointless. So, what parts of the brain are involved in this? Let's break it down. The first key player is the prefrontal cortex. This area sits right behind your forehead and helps with decision-making, planning, and controlling impulses. In schizophrenia, the prefrontal cortex often doesn't work properly. When it malfunctions, it can't effectively process the value of rewards or motivate us to pursue goals. This is partly because of reduced dopamine signaling, which is a chemical messenger that helps us feel motivated and rewarded. Without enough dopamine in this region, people may find it hard to start or stick with activities. Next, we have the ventral striatum. Think of this as the brain's reward hub. It helps us anticipate pleasure and motivates us to seek out rewarding experiences. In schizophrenia, the activity in the ventral striatum is often decreased. This means that even if something is supposed to feel rewarding, the brain doesn't respond strongly enough to motivate action. Inflammation in the body can also play a role here. Elevated markers of inflammation, like C-reactive protein, have been linked to lower activity in this area, making motivation even harder to find. Then there's the corticostriatal circuit, which connects the prefrontal cortex and ventral striatum. This network helps us evaluate rewards and decide whether to act. When this connection is disrupted, motivation drops because the brain can't properly weigh the benefits of an action. Inflammation can impair this circuit further, making it even less responsive. The hippocampus, especially a part called the K2 region, also influences social motivation. This area helps us form social bonds and feel motivated to connect with others. In schizophrenia, the loss of inhibitory neurons in this region can lead to social withdrawal, which is a common negative symptom. Finally, other frontal regions like the anterior cingulate cortex and orbitofrontal cortex are involved in assessing effort and reward. When these areas don't function well, people may feel less willing to exert effort, even when they know the reward is worth it. All these regions work together to keep us motivated. When they don't, it results in the kind of motivation loss seen in schizophrenia. This is why treatments that only target positive symptoms like hallucinations often don't improve motivation. Understanding these brain areas helps us see why new approaches, like targeting inflammation or boosting prefrontal cortex activity, might help improve motivation in the future.